Hello guys, welcome to Inside Electronics. So in today's episode, let's take a look at what's inside one of the most popular aftermarket adapters that you can buy for your smartphone. It's an ERD 5V 2A power supply. The model number is TC50 to be specific, and you can see it has mentioned bad. So let's open it and see what went bad inside that. So I've been using ERD power supplies since the last 2 to 3 years, and to be very frank, I'm completely satisfied with the performance, and I have already tested one of these kind of adapters in a previous episode. If you haven't watched that, click the I button up here. Most of the time when I say that, I actually forget to do that when publishing in YouTube. So if that happens with this one as well, you can just search for the playlist power supplies in my YouTube channel, or you can simply search my YouTube channel itself. So I have, as I said, I have already made a very detailed full load test with one of these adapters, and it seems very good in that test. It performed very well. Not this particular adapter, but a different one. Of course, this one is bad. So as I said, I personally own like 5 of these adapters for many different purposes, and these are not sponsored by ERD by any ways, because I have a lot of different power supplies like this unbranded generic one, and let me show you one which my regular viewers will recognize. This one, it's made by Geek Cases. It's a SIP-Q Plus, and some more adapters like this one is made by Asus, the original charger, and I have a lot of them lying around. Maybe literally I think 25 or 30 adapters are with me, all with different voltage ratings, some with quick charging, some without quick charging. For a person who is working with electronics, especially low voltage electronics, it seems good idea to have many different options available. Like, most of the time I'm not just using these adapters to power up my phone. That can be done by any of the chargers, it's working fine. But most of the time I'm using these adapters for many different purposes. And let's come back to today's topic, which is this ERD 5V adapter. And as I said, these are actually really good power supplies. These have performed well. In fact, the only issue with these are if I have to say some bad thing about it, the only issue that I found while testing it is the issue with the cable, which you can watch in that video. What is that issue? I'm not going to spoil the surprise for you guys in that. So as you guys can see, it took some effort to take it apart, because I thought, like I'm still thinking that it may be hermetically sealed, like friction welded plastic welding or something was going on, because I actually used a hacksaw to cut this thing open. I actually hacksawed a portion and then used a screwdriver, and you can see the damage over all the surface. The effort I put into opening this one, it was really stubborn. It was not coming at all by any means. That's actually a good thing, because you can make sure that this thing will not come under regular usage, and just 1 or 2 folds will not bring it out. That's a good thing actually. But for people like me who do teardown videos, it's actually a bad thing. But for the normal users, it's perfectly fine. And you can see it is BIS certified, and indeed it is very good power supply. And this specific one has a really short story behind it. I purchased it and I kept it for maybe 6 or 7 months, because as I said, I have a couple of them, 5 or 6 of ERD adapters itself, and I kept them in one of my drawers for maybe 5 or 6 months. The warranty period is only 3 months for this one. So after 6 months, one day when I wanted to use it, I took it out, connected it, and I heard a loud boop. So I heard a loud popping noise from this one. Like it was actually brand new. I just took it out of the box on that very day, and just like that I took it out from the box, connected it, turned it on, and pop. The typical burnt electronic smell was coming from it. Oh, for the EEV blog viewers, the magic smoke has been released already. So enough of the history. It's already been 4 minutes. Now let's see the box for its specification, and later on we will go to the actual task of taking it apart. So you can see the input voltage range is 150 to 240 volts AC. AC is 5V 2A, and the features are funny. Stabilized output, low ripple, low interference, short circuit overload protection. Yes, indeed it has short circuit and overload protection. It survived 24 hours of short circuit test in my personal experience, because I have tested these things for a lot of different purposes. So short circuit and overload as well, I have tested both of them individually, short circuit and overload test. It was staying cool even after 24 hours, being short circuited and being overloaded for up to 4 amps. I personally tested that. Still not a paid promotion by any means, and I wish ERD was actually kind enough to offer me like a sponsorship by some means. Anyway, let's move on. High energy, high efficiency and low energy consumption. Okay, high gloss PC cabinet. What in the world is a PC cabinet in this one? I'm not sure what it is. Inbuilt automatic voltage booster. I think it's a 5 volt 2 amp step down thingy, not a voltage booster. Maybe they're talking about the RMS voltage to peak voltage conversion that is happening after the full bridge rectifier. 240 volt gets boosted up to 300 something volts. Maybe that's what they are using, no idea. The mobile charger is TC50 and it included a USB cable, micro USB in this case, and I actually am using it somewhere else. So let me give you the brief on the side. You can scan it if you want. So these are the sides, made in India proudly. Yeah, that is one thing I think I forgot to mention in this video. ERD adapters are made in India. It's not a Chinese product. It's a good quality BIS certified product designed in India itself. They are actually using some Chinese things inside. Obviously the whole internals of every adapters are now Chinese. So now, after around 6 minutes of talking, let's move on to the actual bits and pieces that we are interested in. So it is actually a slide mechanism that had 2 locking pins, one over here and the one obviously is no longer there, but it was there, and those 2 were actually used to hold it together like that. And the AC adapter side is actually pushed into the main PCB using those kind of clips, which I shall focus on to right now. So that's the clip that pushes it onto it, and you can see the rust started to happen. And that is one more bad thing that I think about these adapters, because this adapter was sitting inside the drawer for the last 6 or 7 months, and oh, let me tell you one thing, like this incident happened like a few weeks ago. So, and if that is the state of this thing after being sitting just idling for 6 months, I wonder how long it's going to survive. But anyway, maybe it is exposed to some bad weather. And let me show you what went pop. You can see inside over there. So that's the bottom side, and you can see clearly the suiting over there. And now let's move on to the interesting bits and pieces. Already 8 minutes have passed. So on top, it is very simple. There is an MOV at the input side. There is an inrush limiting resistor, I believe, and that is also burnt in this case. I'm not sure whether you can see that it has suffered some damage. And then moving on the top side, there is the main filter capacitor, maybe 450 volt 10 microfarads, made by Sancon. This must be the bootstrap capacitor for the IC, and this is the suppression capacitor, class Y suppression capacitor for the noise filtering. This is the transformer, switching transformer, another output smoothing capacitor, I believe, 105 degrees, 6.3 microfarad, 6.3 volts, 470 microfarad. It's a single USB port, and on the bottom side is where most of the interesting bits are happening. So you can see the bottom side, the main switching IC is what took the damage. So I believe what caused this damage is, with these kind of electronic equipments, when you are plugging it into your wall and when you're turning it on, you are not sure at what point of the AC sine wave you are turning it on. Maybe you will be turning on at the positive, like at the zero crossing point itself, but it's very unlikely you do it every single time. But maybe at one time, or maybe when I did it, I must have turned it on when the AC sine wave was at the peak of the voltage. So in a brief moment, this IC has received the full rectified AC voltage, which it was not preparing for. So maybe that, let me just open the window. Maybe that was the reason why it actually suffered that much of damage. So let me give you the bottom view, and this IC was actually DP1805. Let me show you the datasheet for that IC. So this right here, guys, let me turn off this light to give you a much better view. So this right here, why is it not? Yeah. So this is the IC that they are using. It's a DP1805 quasi resonant PSR CCCV PWM power switch. So you can see it has all these features, and it has short circuit protection, cycle by cycle current limiting, leading edge blanking. That's a good option. Or voltage, under voltage, over temperature. Yep. And this is a circuit that they were following. This is a single page PDF that mentions everything, and this is a circuit that they are following. So this right here, guys, with their own values is what they must be using. Possibly because there must be some other pages, because it says 1/11, so 10 pages are missing in this particular PDF. I got it from the company's official website itself, but still with just one page. So I'm not sure whether the values they have used are actually mentioned at the remaining pages, but anyway, we have no other way to know about it. But this is a circuit of an ERD 5V adapter. So moving on, let's turn this light back on. And this is the IC DP1805, and you can see it actually has exploded. Over here you can see it actually has exploded, and you must be wondering how I know it is actually DP1805 if it was exploded. So I will show you how I took the how I came to know the part number. I'll put a picture on the screen right now. And another picture which shows how I took that photo. So yeah, that is one thing. And this right here, guys, this is a different IC over here. Let me focus on to that. P41150. That must be a MOSFET, but looking at the connection, I think that is a MOSFET, because the gate is the only terminal that is separate. Others are all connected together, so that must be a MOSFET. Okay, so here's me again quickly cutting in from the future to correct a mistake. It turns out that this MOSFET looking thing is actually a synchronous rectifier. It turns out quite obvious when you look at the secondary side, and there are no other switching or rectification components on this side, not even a single diode. So when I went through the datasheet, I was able to find that this is actually a synchronous rectifier. So it turns out that the manufacturers are actually aiming for a better efficiency, because most of the time a simple rectifier diode will do the job, and also that is what is recommended in the datasheet for the DP1805. I'll show you that over here. You can see the manufacturer just recommends using a single diode. But the problem with using just a diode is that when the current flow increases, the heat dissipation also increases. So the diode on its own will drop around 0.3 or 0.6 volt across it based on the current flow through it, and that is just dissipated as heat. So whenever there is a heat being generated in a circuit, the efficiency goes down. So in this case, the designers wanted to avoid that, and that's why they have used an active rectification method. So the circuit is very simple. It's just 3 pins, and I will show you the datasheet for that. By the way, the part number will be KP4110, which is this one. Let me turn off this light. So you can see it's a secondary side synchronous rectifier, and this has all the features if you want to see that. And this right here is the circuit diagram. You can see the pinout. It's a drain, ground, and VDD, and it can work on the high side and on the low side, the return path. So this is the most simplest rectifier that you can get. And in fact, there are synchronous rectifiers available in the 2-pin diode-like package, which will look something like this diode over here. So it will look just like a diode, but it is actually a synchronous rectifier. So coming down, this is the very simple circuit. It just derives its own power supply from the output side of the transformer itself. You can see the pinout, and this is the pinout, drain, VDD. So this is the pin description, and let me show you what's inside this IC, where the good things happen. So let me just zoom down a little bit, and this right here, guys, is the internal of this IC. So you can see it has a primary side detection going on, it detects a current flow by making use of the forward diode, the body diode. If there is any current flowing, it will detect it through this circuit and it will then turn on the MOSFET. So the turn on resistance, the on resistance of the MOSFET itself is very low compared to the diode, so the most of the current will flow through the MOSFET itself. So it's because of this low resistance of the MOSFET that they are able to achieve very less voltage drop, still achieving rectification, because they are turning it on at the positive cycle, every positive cycle. So in a sine wave, this circuit detects when the cycle is in the positive range, that is on the upper half cycle, it will let it pass through the MOSFET. So the positive half cycle will reach the output side, and during the negative half cycle, which is on the negative side, it just disconnects the MOSFET from the circuit. Also, when the diode becomes reverse biased during the negative cycle, that way it will not conduct through the body diode as well. So that achieves a half-wave rectification in this case, but with a higher efficiency, because the on resistance of the MOSFET is very low, it dissipates much less heat when compared to an ordinary conventional diodes. So that is the way they are achieving a higher efficiency by making use of this circuit over here. And you can see in here it actually derives its own power supply from the VDD and the drain. So it's basically the source, the drain, and a separate VDD for the whole functioning of the device. It's like a source and drain for the MOSFET. So it's almost like a MOSFET because it makes use of a MOSFET, but the functioning is purely different. The ground pin acts like a ground pin for the internal ground as well, or the source, or shall I say the source acts like a ground pin for the whole internal circuit as well. So that is how they are achieving a better efficiency. And it turns out that the designers of the circuit were not blindly following the datasheet for the DP1805 IC recommends. They have actually done some modifications to the schematic, like these extra resistors. These were not mentioned in the schematic either, this one and these synchronous rectifier stages as well. So it turns out that this is actually quite a good little component right there to improve the efficiency. Okay, going back to the video, you can see there are some resistors connected across the data lines, that the center pins of the resistor is connected to the data lines just to indicate the device, whatever device you're connecting, that it is capable of delivering up to 2 amps. And the smartphone devices are actually capable of sensing some voltage on these, and depending on that they will communicate with the adapter to know what is the maximum amount of current that can deliver. And you can see the 2 pins going on over there. It has a very good enough separation. Not just good enough, but it is good, because otherwise they would not get the BIS certification. You can see an anti-tracking slot cut on that side. You can see on this side all the power resistors are burnt, probably the sensing resistors, and nope, they are not sensing resistors, they are coming directly after the full bridge rectifier. That means these will be for the power supply rail of this one for the IC. So that is where most of the damage has happened. All the resistors are burnt out and the IC itself is burnt out. But overall, this is a pretty nice EC power supply. If we can get a replacement for this, I think we can buy it from Chinese websites. It's actually repairable as well. We can get it repaired if you can find this IC at a reasonable cost shipped to your country. In my case, I'm not going to repair it because I don't have a requirement to repair this thing as of now. If I have them, like maybe when all of my 5V adapters, ERD adapters have failed, I may try to order a couple of these if there is a failure mode on that one as well. But as of now, I think that concludes this video. It's actually a pretty good puzzle. If you're looking for an aftermarket power supply with a very good rating, you can blindly go for this ERD adapters. I'm saying it again, this is not a promotion by any means. These guys, just because it's an Indian product, I'm supporting them that way. So then again, you know, this being an Indian product, they're using a Chinese IC inside, so I'm not sure whether to say it's a fully Indian product, because the heart of operation is still coming from China. So that's the way electronics nowadays are. So I think that's it regarding the ERD 5V adapter. You can see the model number TC55D mentioned over there, but in here it's mentioned TC50, maybe something else. And this is the first revision of this PCB as well. Maybe the PCB or the schematic, I don't know, but it says revision 1 over here. So they are just in the beginning stage with these 5V 2A power supplies. Moving on, and if you have one of these kind of adapters, and you don't want to repair them, you can actually salvage these full bridge rectifiers. And this is a section where they might have saying inbuilt automatic voltage booster, because right after this full bridge rectifier it will be around 300 and something volts. So the MOV is there for the protection against high voltage spikes at the input. If what is it rated for actually? What is that MOV rating? It's rated for 51051. Anyway, I'm not able to read it properly. I'll put it in the screen right now. That will actually protect it from, if the voltage at the input side goes above that particular voltage, it will actually pass through the MOV before reaching any of the circuit. But in this case it didn't even work, because certainly that voltage was still under 240 volts, but it is at the wrong time we turned it on that caused the issue. So I think 18 minutes for a power supply is way too long, and maybe it's time to conclude it. So yeah, that's it regarding the ERD 5V 2A TC50 power supplies. Thanks for watching guys. See you in another video.